Physics chapter 20 ideal gases theory video 1. um, so here first of all you need to know what Brownian motion is. So you have studied in O levels how Brownian motion works. You have learned how particles are in random motion and how they collide with each other, these particles, and you have observed it under a cloud chamber. Then Newton's laws of motions, you need to be familiar with them, and also how momentum changes is also something that you need to be familiar with before you study these things. If you have any doubts, please refer to earlier videos or the textbook and get familiarized with all of those facts, and then come back to the video. So one other thing that you need to remember when it comes to a gas, you know that those particles take up the volume of the container in which it is contained. Then unlike liquids, gases are compressible. So that means its volume can be decreased. So the relationship between volume and pressure you need to understand. So if you reduce the volume, then the pressure is going to increase. So there is an inverse relationship in that. So that is something that we are going to discuss in the lessons. Then there is a relationship between temperature and also the volume and pressure as a result. So that is also another thing that we are going to discuss. Then at the same time, you need to remember in our earlier lessons we learned that the internal energy is increased when we increase the temperature. So kinetic energy is increasing. So that is the principle that is being used here in these balloons. We call them hot air balloons. In this particular situation, in these weather balloons, you have a lighter gas in it. A gas lighter than air. So when it is lighter than air, they will be pushed upwards. They will rise because the atmospheric pressure keeps it rising. Hot air balloons also do the same thing. It increases its volume. As a result, its density reduces. Because its density is low, it goes up to where the density is low. So those principles are vital in in learning this particular lesson. Then we know that everything is made up of particles. Some particles are closely bonded like in solids, but in here in gases the particles are in constant random motion and they bounce off the walls of the container. As a result, there is pressure generated. Then they are not actually moving in a organized manner. They are moving about in a disordered way, right? And also the most of the gas is empty space, right? Then in 1820, Robert Brown discovered how these particles move, and this to honor him, we have named this movement Brownian motion, right? And they have this haphazard and jerky motion because they collide with one another, right? So how he saw that was actually this, just like seeing the smoke particles. The air molecules are very tiny, they cannot be seen, but the smoke particles get bounced off each other, not only because of these things, but because of the air particles are as well. Then the pollen and dust particles are big enough to be seen, but air molecules are too small. But still, when they collide, they change their directions. Then um, then we come to discuss something called fast molecules. Uh, for standard temperature and pressure, so the standard temperature and pressure means STP, this is not room temperature. Remember that this is standard temperature and pressure. It is 0 degrees Celsius and 100 kilopascals. Then at this speed, uh, at this temperature and pressure, standard temperature and pressure, the average speed of a molecule is about 400 meters per second. So that is quite large, right? So you need to understand how big a speed this is, right? You know that uh, sound travels at 330 meters per second. So how is that possible? You need a material for it to pass through, right? So now air molecules, in air, the speed of sound is 330 meters per second. So that actually justifies that very high moving speed of molecules. Because sound can travel 300, the reason why sound can travel 330 meters per second at STP is because these particles are moving at very high speed. It is not, now for example, if a person is there 100 meters away, he is not actually hearing me. If I shout, then he will hear me, but he is not hearing me because of the power of air that is coming out of my mouth, because these particles actually have the ability of colliding, and it has a natural speed of 400 meters per second. So considering all the other obstacles and all the other the time that is wasted when collisions occur, it travels at 330 meters per second, right? So this is the average of average speed. So average means at any moment there are particles which are higher, which are traveling faster than this, the 400 meters per second, and there are particles which travel at a uh, lower speed, lower than 400 um, meters per second, right? Uh, then all of these things are going to change depending on their collisions, their velocity, that is the magnitude and the direction will change when it collides with something else, right? So you have learned in other lessons about elastic and inelastic collisions, so they are common for all collisions, so it applies to this as well. um, then if there are particles that have the ability of moving much faster, right, that is very much faster, they can have the ability of escaping Earth's gravitational field. So you have learnt in gravity that if it gravitational movement, in our earlier lessons we discussed that if an object is fired at a higher speed, then it will actually leave the Earth's gravitational field. We discussed about that. So if something is to go into orbit, it has to be fired in that particular range. So now the escape velocity is 11 kilometers per second, right? So as a result, our atmosphere is still intact. That is because most of the particles don't have that escape velocity, right? So the average is 400 meters per second. If the particles had that higher velocity, then obviously we won't be left with an atmosphere. So you have to remember that. But there are particles that do escape. So that means they have a higher speed than that, but that is occasional. Let's write a note and then go to the next lesson. Write down particles of a gas. Gas particles move in a haphazard and jerky motion. Particles move in a haphazard and jerky motion which is resulted by collisions with other particles, and this motion is referred to as Brownian motion. Remember, this haphazard and jerky motion is due to the collisions. Leave a line and write fast molecules at STP, that is standard temperature and pressure, 0 degrees Celsius and 100 kilopascals. The average speed of an air molecule is 400 meters per second. So this is a very high speed comparatively. So if you compare the speed at which, the highest speed at which you can travel on the expressway, it is 100 kilometers per hour, right? If you convert that into um, meters per second, it becomes a very low amount. Okay, it's a very low amount. The fastest man on earth runs at a speed of about 11 meters per second. 11 meters per second. The fastest man runs at 11 meters per second. So here we are talking about 14 meters per second, right? So that is very high. So the average speed is about 400 meters per second. This suggests that some molecules move faster than this and others move slow at a rate slower than this. Their velocities, within brackets magnitude and direction, always change because of collisions. An air molecule can escape Earth's gravitational field if it reaches a speed of 11 kilometers per second. Right. So then, explaining pressure, we have discussed this in great extent in all levels. A gas would exert pressure on any surface that it comes in contact with, and you can remember how pressure exerted by fluids, that is gases and liquids, how they differ from the pressure exerted by a solid surface. So when you press hard on a table or on the surface of the table, you are exerting a pressure only towards the table. It does not apply in any other direction, but in fluids it acts in every direction. Then pressure is a macroscopic property, and it is defined as the force exerted per unit area of the surface. Then an atmosphere is you can actually figure out that it acts in every direction by sucking out all the air out of a plastic bottle. Then it will get crushed it gets crumpled. The reason it gets crumpled is because it acts in every direction, not only from above or not from only from above. It gets crushed in every direction, suggesting that air is this pressure is acting in every direction. Then the pressure of the atmosphere at sea level is approximately 100,000 pascals. Then the surface area of a typical person is 2 meters per 2 square meters. Hence, the force exerted on a person by the atmosphere about 200,000 newtons. So this is equivalent to the weight of about 200,000 apples. So just imagine the pressure that we are used to. Remember, we are used to this pressure, so we can live without any problem, right? So we actually have a force that is the force inside our body has balanced out the outside force. That is the reason why we are still alive, right? Because equal and opposite force. But when you create a vacuum, it gets crushed. um, um, uh, then if you take a single molecule of air, it continues to if it is contained in a box, it would bounce off the walls, colliding at different surfaces of the box. Then when there is a collision, it generates a force on the box. It exerts a small force on the box. So this force is acting on that area. So as a result, there is a force generated. So the force acting on an area is pressure. So when there are large molecules colliding like that, there is a big pressure generated, right? So then the pressure created by a gas depends on two factors. The first one is the number of molecules that hit each side of the box in 1 second, right? And then the second one is the force with which a molecule collides with the wall. So that means if it has a higher force, means it is moving faster. So that means if it is warm, then it has molecules moving faster. As a result, creates a higher pressure on the walls. uh, uh, then if a molecule of mass m hits the wall head on with a speed v, it will rebound with a speed v in the opposite direction. The change in momentum of the molecule is 2mv, right? Since force is equal to rate of change of momentum, right? Since now force is equal to the rate of change of momentum, so as a result, higher the speed of the molecule, greater would be the force that it exerts when it collides with the wall. So as a result, pressure on the wall will increase when the molecule is moving faster, just like I explained earlier. uh, Now here, if the piston in a bicycle pump, that is the pump that is used to fill the tire with air, if you keep when you push it inwards without changing the temperature, then the molecules will hit the piston each second. But now uh, but the collision will produce the same force. Why? Because the temperature uh, because the temperature is constant. So as a result, the average speed is going to be the same, right? But there will be increased rate of collision. Without talking about the temperature itself, we can say that the pressure is rising because there are higher collisions, right? Then if now when the temperature also increases, then there will be more molecules moving much faster. So then both of these things, not only the reduction of the volume but also the increase in temperature, will affect the pressure to rise. So those are basic principles that you need to understand, and this is the box that we spoke about earlier: individual particle colliding with each other. Write down a note. A gas exerts pressure on any surface with which its particles collide. When the pressure of a gas is increased, two factors come into two factors come together to increase the pressure. Number one, higher number of molecules hitting each side of the container. Number two, the increased force with which molecules collide with the walls. When a molecule of mass m hits the wall head on with a speed v and rebounds with a speed v in the opposite direction, the change of momentum is 2mv. Because force is equal to rate of change of momentum, higher force means higher speed of the molecules. As a result, fast moving molecules will increase the pressure. Reduction, leave a line and write, reduction in volume increases the chances of collisions by reducing the surface area. And an increased temperature increased temperature increases the increased temperature increases the speed of the molecules, resulting in pressure being increased. I hope you understood. Please do question number 1 and 2. If you have any doubts, please ask me.